Here's our next one. It is integral fraction bar top x cubed bottom open parentheses 4 minus 2x to the fourth close parentheses to the 11th dx. This one's a little bit of a jump up from the last one, but we'll see if if you're feeling good with this and you want to try it. Look at the timestamp, then you can go ahead and do that. If you want to just keep absorbing, then that's fine too. This one's also different in that it has negative exponents. So, here we go. Hopefully you see that the u is that piece right there. This piece is interior to the 11th power in the denominator. And then look, 4 would derive away. Negative 2x to the fourth would derive to something times x cubed, which is what I have up here. So, we're going to make u equal to 4 minus 2x to the fourth. Now I'm going to, hold on. So I'm going to ddx this thing, which gives me du dx is equal to, I should say this is the first one where it's like you kind of want to use u sub. Some people could do it in their head, but I suggest using u sub. All right, so I get negative 8x cubed. From there, I need to multiply by dx. du equals negative 8x cubed dx. And maybe now I'll rewrite this a little bit. If I had 7 over 3 times 10, I could write that in multiple different ways. I'm trying to show you what you can do with this thing. I'm trying to show you that this thing is the same as the integral. I'll write it with a 1. 4 minus 2x to the fourth closed to the 11th. I can put this x cubed dx like that. I can move this guy into this space right here. Because if I had 7 over 3 times 10, yeah, I could write that as 70 over 3. But I could also write that as 1/3 times 70, where the 70 here is the product of these two. So that's what I've done here. I left a 1, that's this one, 7 moved here, the x cubed moves here. Hopefully you see that. Let me get rid of this stuff. Okay, so now look what I have here. I got x cubed dx, I got negative 8x cubed dx. So what do I got to do? I got to divide by negative 8. So that gives me negative 1/8 du equals x cubed dx. So now let's see what pieces we have. This guy is that guy right there, whole thing. So I'm going to replace all this stuff in right there. And I'm actually going to move the 1/8 over out of the way from the get-go. And then I've got this right here, is that right there. So this is going to replace that. And then that gives me that this is equal to, I'm going to move the negative 1/8 out the front of the integral because I can. And then I get 1 over u to the 11th with a du. You should see that all of the parts of this are in here. The du is this, the negative 1/8 is that, and everything's being multiplied, so it's equivalent. And then I have 1 over u, this guy, to the 11th. So that, I'm going to write it as negative 1 over 8 integral u to the negative 11th du, which that is going to give me, all right, I'm going to write my negative 1 over 8. I'm going to do a power rule. I got my number line. Here's 0. Here's negative 11. I got to go up 1. That takes me to negative 10. U to the negative 10 like that. But then I got to divide by that because that's part of power rule. 1 over negative 10 in parentheses. I got a double negative there. That gives me a positive 1 over 80. And then I'll write it as u to the negative 10th plus c plus c. And then let me write that. Actually, here, what I'm going to do is, instead of writing u to the negative 10th, because that's already written there, let me write it as times 1 over u to the 10th, like that. Because we always want to give our answers with positive exponents. So what's that? Leaving me with 1 over 80, open parentheses, close parentheses, to the 10th, plus c. Now I just got to find what u is. Oh, there it is right there. 4 minus 2x to the 4th. Bam. So that's our answer. This is that. If you left and tried it and came back and got this, I am so impressed. If you left and tried it and got something close to this and made a small error, I am still so impressed. If you tried it and tried to do it, I'm impressed. If you listened to the whole thing, I'm impressed. I'm impressed with all of you. Anyway, seriously though, I think y'all are doing a great job. Let me do one more example. And this one I think might be a little bit easier than that one. So what are we? That was 5. So let's do example 6. Integral of 5x times e to the 3x squared plus 1 with a dx on the outside. This one I think you might be able to do. It's a 5. It's a terrible 5. I don't have good 5s. I'm sorry. Okay, so see if you can try it, and then I'll give you a timestamp. You come check it, or if you just want to listen, then you can listen as well. Okay, so let's identify the u. Well, let's rewrite it first. This is the integral of e to the 3x squared plus 1 times 5x dx. Oops, can't get my colors straight. This is going to be my u. U equals 3x squared plus 1. Now I'm going to ddx this. So I get du dx equals 6x. And then the 1 derives away to nothing. So if I get du, it is 6x dx. And look, I got a 5 here. So let me show you how to do this easily. I want a 5 there, and I want to get rid of the 6. So I need to divide it by 6. I'll draw an arrow here. I'm going to divide by 6, and I'm going to multiply by 5. I'll show that out. That gives me 5, because I'm multiplying, over 6 du equals 5 over 6 times 6 dx. Oops, I missed my x. X dx. And see why I'm dividing by the 6? Because I want to get rid of the 6. And see why I'm multiplying by the 5? Because I want the 5 to show up there, because I need to match this piece right here. So that's why I divide by what I have and multiply by what I want. It wasn't quite as easy as the one where I just had to, I had a 5, I had to get a 10, so I'd double, right? Anyway, hopefully you see that, because that gives me that 5 over 6 du equals 5 dx. Normally you wouldn't show this much work to do this. You would just do this line, and then maybe bump right to this. And I think you guys will be able to do that pretty soon if you can't already. So I should highlight this is this. So this will replace that. And then this is this. So this replaces that. So we get, I'll write it in a couple steps. I get integral of e to the u times 5 over 6 du, which I can take the 5 over 6 and move it out front of the integral. Integral e to the u du. And you say to yourself, what derives to e to the u, or what derives to e to the? Well, it's e to the. So when I integrate this, I just get 5 over 6 e to the u plus c. And then my last step is to plug in what u was, which is this thing. So I get 5 over 6 e to the 3x squared plus 1 plus a constant, Bam. Hopefully you're feeling it. You're good. I'm going to give you a couple practice problems, and we'll do some more in a day or two. Bye.